Welcome. So in this part, the final part of this lesson, we're going to see cubics with one axis intercept. So cubics of the form this have only one x-axis intercept. We've seen this before. This is where you have a point of inflection. But then we keep reading. Some other cubics also have only one axis intercept because when they are factorized, they're found to have only one linear factor with the other remaining quadratic factor unable to be factorized further. Usually you use your CAS for these questions. So let's look at this example right here. And as you can see, I have a linear factor here and I have a quadratic over here. Now this quadratic, what we're going to find out can't be factorized further, which means we're only going to have one x-intercept at this one right here, at x equals 1. But of course, we can't just assume that this can't be factorized further. We have to prove it, and we prove it by using our discriminant. So I'm going to use my discriminant here. B is going to be 4, so it's going to be 4 squared is 16, minus 4. A is going to be 1. C is going to be 5. So that means I'm going to get 16 minus 20, which means it's going to be negative 4. So that proves to me that this quadratic right here can't be factorized further. So that's where we're at. So the only thing we can say is that we have an x-intercept at 1. We have an x-intercept at 1. We also know that we have a reflection taking place. But this is where we're going to use our CAS. So let's get our CAS here. And let's graph this. So we have negative brackets x minus 1 brackets x squared plus 4x plus 5 brackets, hit that. And we have something that looks like this. Now we could just find some key features of this just to help us sketch it. So what could we find? We could find our turning points. So remember, in the previous examples, we couldn't find our turning points because we didn't have our CAS, but now we can. So let's find this turning point right here by using our maximum. Let's go analyze, let's go minimum, let's find this one. We could also find our y-intercept. Let's go trace, graph trace, and then we know that it's going to occur when x is equal to 0, so we go 0, then we hit enter, and then you can see that it's going to occur at 0, 5. We also know that we have an x-intercept at 1, and we can just confirm that by going analyze graph 0, and sure enough, it's going to be 1, 0. So now, with all this information, we can give this thing a sketch. So I'm just going to put this graph on this screen here so I can have a look at it while I sketch it. So it's going to look something like this. Now excuse my terrible drawing. Okay, it's going to look something like that. It's important that when you're doing it, that it has a bit of a curve to it, you know what I mean? All right, let's just leave it like that. Otherwise I'll just keep embarrassing myself. So we have a turning point there, we have a turning point there. We know that we have a y-intercept at 0, 5. Which we found using our CAS. We have an x-intercept at 1, 0. So that's generally what our graph is going to look like. So by finding our turning points, our y-intercepts, we did this using our CAS. How ugly is that? We did this using our CAS to do this. And the reason for that is because, we couldn't have done this without our CAS because we can't factorize that any further. So it just makes these kind of questions really tricky without your CAS calculator. But hopefully you found this useful as going through it. You can now begin your exercise. And let me stress for the final time that the exercise does ask you to do sign diagrams, but you do not have to do them. Good luck with your exercise.